Hi, my name is Keenan Hardert. I'm a biology professor at Minnesota State University. I perform cancer research and also bioeducation research, which is up on screen. Today, we're going to be focusing on how to use Prism's new data wrangling, extract, and rearrange analysis tool in multiple variables. So this one's good. This is going to save you all kinds of time because you can go from this big mothership of data right here and do the advanced analyses that we've seen already, where you can make, for example, these great XY color and size graphs, heat maps, things like that. Perfect. But if you wanted to do sub-analyses of the data that you already have, there's a way to do that instead of just making a ton of files like I kind of used to make even. So let's go ahead and take a look in here. If I wanted to look at something specific, here's everything right here. You're going to go to multiple variable analyses, go to extract and rearrange. You can click everything because everything will be a choice for you to kind of zoom in on, to call it that. Now, on here, you have different choices of which data you could basically extract and filter and say, I want to perform these small analyses using these setups right here. So let's do an example. This is also going to take you to Prism's other functions, like the strict XY function. We're going to go into that, but only with the data that we want. So if you click data arrangement, let's say that I want to say, I think that the first exam is actually going to predict just the overall class percent. I'm going to group this by, in this case, did people come to the review sessions or not? At least 3 or more times. Let's take a look at this. So first off, the results tab is going to actually get this right here, kind of get you a nice filtered setup for the high review people and the low review people. And these are their final class percents versus the exam 1%. All right. So now looking at this graph, we have a great little XY, really nice and standard. I'm not going to take too much time on here and do like a ton of formatting because I have to move on. But in this case, again, I can tell you right now, the ones that go to the review are just basically a little layer on top. Um, and you can do all the same functions that we've been doing in some of the other videos. Get that all set up. And let's say that I am in high attenders. I want them in a nice little green. And we are going to have low attenders. Poo poo. And they're going to be in red. Oh, see, look at that. Go to office hours, everybody, right? You can do all of your natural standard, linear regressions, things like that right here. Great confidence interval bands, all good. And see how we extracted that and rearranged it from the giant mothership right here. So let's do another extraction here. Extract and rearrange. This time, let's just say we need to make a quick t-test setup, or we can do a one-way ANOVA right here. So I'm going to do a quick t-test. I'm going to say, all right, again, kind of just taking a look here. What is my continuous? I want to say, what was the average exam for people that did you come to the reviews or not? I think, oops, sorry, there it is. Did you come to the reviews or not? How was your exam? Okay, it's going to extract for me right here. And we are in column format immediately. And we can do all the same t-test values, totally set this up nicely. Yep, there's our Welch's t-test, obviously significant. And you can go in and do all the same Prism functions as always. So perfect. And if I wanted to go back up here, I do have a few variables that would be good for a one-way ANOVA. So if I data arrange and I say, all right, I want the average exam for each semester, and I've got 3 semesters. So let's take a look at this. All right, there's every semester. There's everybody's exam. Each patient is still in a row. All right, look at this. Look at that. My spring, they were the top ones. Yeah, my fall 23. Oh, shoot. That said, then anyway, you're going to do a nice little setup here. Compare the mean to each column for an ANOVA. Okay, the general ANOVA was good. Oh, dang, look at that. So fall 23 was lower than spring 23 and same for fall 24. Dang, that spring 23 class actually kind of came through. All right, so next, let's go back to analyze, extract and rearrange. This time, we're going to get a little more complicated. Of all parts of this video, this is my favorite right here, okay? Arranging a two-way ANOVA setup is really tough because you're doing a sub-column within. So for this case, I want to know, let's give this a shot here. Oh, sorry, yeah. So you got to obviously do the data arrangement. Response variable, I want to see again, I want to see this average exam score. Row factor. because now we're going to have in each column. So the columns that I want, I'm going to do semesters again, actually. So now each column in each group is going to be which semester. The row factor, though, I want to see if they had high work commitments, high or low, how that's going to do. Now, in this case, subject variable, this is another sort of subcolumn tool. I'm not going to run through it right now. You can if you want, because I wanted to show you this. Here are my high versus low committed students, right? Look how many replicates are right here. Look what it would have taken to arrange this in a spreadsheet, right? And I know here, sorry, I'm even my spreadsheet's kind of slowing down. Because I mean, I've got hundreds of replicates in each one and they're uneven like that. And there's spring. See how I'm doing this in each semester? That would have taken me a long time to rearrange. That one right there is the most powerful tool on here for me. And now, excellent. I've got these numbers all set up. I could switch these axes if I wanted, then do row versus column, and I might actually end up doing that. But in this case, I can say, hey, like I want you to run this two-way ANOVA for me. I want you to, do multiple comparisons for me. Cell mean and cell mean, for example. Let's take a look. Yep, I mean, it's going to tell us row and column factor setups. Is there going to be a difference with these ones? Everything like that. I mean, the big thing that this also is offering, again, like I said, is mainly that data extraction to just get to this point, just to get to this point so I can say, hey, I want to arrange this how I want. So for example, if I want to do my cool individual values, I could do median with 95% confidence interval like I like. I gotta make the colors on the bars show up better. But in this case, no, I really like this, and this is going to offer that two-way ANOVA setup where you can compare different columns, the groups, the rows to each, everything like that. This would take a long time to manually set up in a spreadsheet, but not with extract and rearrange. All right, last great tool to set up is one that, again, you can still use for strict analyses like I'm about to do, but this is also just really good for summarizing this massive pile of data right here, right? So let's say again, I want to say, here is my, I'm going to say recommended, trying to think. The column variable, yeah, let's do semester again. And then treatment is going to be, yeah, I'm going to say, did you have high commitments or not? So what this is going to do is set up in a total how much are of each subcategory totals that. So if we go to results here, notice here, in fall 23 is about 90 students. Each of these classes has about 90. And I can see how many I have working high, 20, which is like 20 hours or more outside of school. In that first fall, it was over 50. But you can see right here how cool it is to at least even just visualize some of this. And you are going to be able to perform stats on this as well in the contingency table function that Prism offers. So I'll go up here. I'm going to do a chi-square in this case because I like Fisher's when it's just 2 and 2 in that case, but a chi-square is still going to tell us, are we high amount of squares difference from expected versus observed? And we are. Nice. But what this is also really going to help out with is, I gotta find it. Oh no. Ah, I want to find the row factor and all that good stuff. Like the percents for each one. I think if I just scroll the right way, must have to go over here. Analyze table again. Yeah. But in this case, oh, it's not going to let me. And I don't know if it's going to really let me do Fisher's. Yeah, it shouldn't. That's not the right data for that. Anyway, so this will also be able to compare each factor against one another, things like that. I think if I wanted to make this a little cleaner, what we'll do is a Fisher's test where I'll just choose two things instead of a factor that has three, like the three semesters. So let's do this quickly here. Fisher test. I want to see the outcome variable. I wish I had one that was a little higher. I think I just have too many yes and no's. Let's try this. First gen versus are you working more? Let's try that. There we go. Okay. Wow. Okay. When you are first gen, of the 47 that they've got here, almost a little under half are working heavy hours versus over here, not as much. This is actually a pretty good finding right here, although it may be a little obvious to those of you that did pay your way through college. Dang, there you go. So I am first gen versus I'm not. And again, I could switch those back in that column and say like, which one do I want to be the column versus the row factor? In this case with the Fishers though, I am just going to run through here. And now I can say, all right, technically not significant, but these percentages down here are going to help me kind of inform like, hey, 44% of first gens are working heavy duty hours, where only 36% of non-first gens are working that amount. You can also do some row factors right or row totals right here instead of columns, and again, kind of see something along the same lines. But regardless, these are some excellent tools. Like I would sit here and make this video a million hours long and make you watch me rearrange and do all kinds of stuff, especially this setup for 2A ANOVA. That's going to save me so much time. But anyway, thank you all so much for watching, and we will see you in the next video.